Hey guys, welcome back to my brand new video. In this video, I'm going to be teaching you all about refraction of light at plane surfaces. So guys, refraction of light at plane surfaces. So what is this about now? Refraction. Okay, it's written while passing from one medium to another. While passing from one medium to another, if the light slows down, the second medium is said to be optically denser than the first medium, and if the light speeds up, the second medium is said to be optically rare than first medium. This is called refraction. And they have given about rarer and denser. Now, we're going to talk about refraction of light. What is refraction of light about? Refraction of light so guys, refraction is all about, it's written here, we're going to highlight it, the change in direction of the path of light when it passes from one transparent medium to another transparent medium is called a refraction. It is a surface phenomenon. Refraction is a surface phenomenon. Okay. Now, we'll erase this. Okay. Now, as you can see on the right hand side, we have diagram number 1. It shows that an incident ray, refracted ray, and reflected ray and refracted ray. Okay. So this is an incident ray. This is an refracted ray and reflected ray, refracted ray. And as you can focus here, it is rarer. The incident ray is coming from rarer, that is air, to denser, that is glass. So here is the normal, here is the angle of incidence. So this is the angle of incidence, and when the line when the incident ray passes from here, it goes to this medium of glass block or something, and this is a refracted ray. The angle between the normal and the refracted ray is the angle of refraction, this part. Okay, so here as you can see, this is the diagram, the same thing, but here it bends a little because it is going from denser medium to the rarer medium. Now in the next, this is going, the incident ray over here, this can be asked in your exam. So the incident ray is going at the angle of 90 degree, and striking at the medium. Therefore, the angle of refraction is 0. It's written over here, angle of refraction is 0. Then, next, we'll go to the next page. I hope you understood this. Then, this paragraph you have to read. So I'll highlight it for you guys. Okay. So when a ray of a light passes from one medium to another medium, its direction changes because the change in speed of light in going from one medium to another. In passing from one medium to another, if the light slows down, it bends towards the normal, and if the light speeds up, it bends away from the normal. The speed of the light changes, but the direction of the light does not change. Hope you understood. Then, this is very important. You have to remember these 2 points. So the incident ray, the refracted ray, and the normal, I'll just draw it for you guys. So imagine this is the medium, okay, and this is the normal, right? The incident ray, the refracted ray, and the normal at the same point of incidence all lie in the same plane. This is a plane, this is an incident ray, this is a reflected ray, refracted ray, and this is all same at the point of incidence. Right. And guys, you have to remember this also, the second part of it. Yes, sorry. We'll just do it again. Okay. So sine I divided by sine R is equal to constant. So this is a constant sign. It's like this 1, 2. Okay. And sine I by sine R. If you don't know what is that, just read this. The ratio of the sine of the angle of incidence I to the sine of angle of refraction R is constant for the pair of given media mathematically, right? Now, if you go on the right hand side, you'll get to see the speed of light, which is important. Speed of light. Speed of light is 3 into 10 to the power 8 meter per second. Then, remember this formula. Speed of light in vacuum or air, that is C, divided by speed of light in that medium, that is V. So they can ask it. So the refractive index of the transparent medium is always greater than 1. Okay. Now, in this box, as you can see, you have to remember only 4 things. That is the vacuum, air, water, and diamond. Now, skip this. We'll go to our next part of the video, and this one is the speed, the constant formula. The speed of light in medium 1 divided by speed of light in medium 2. Okay. Then if you go down, you will get to see the there you will get to see okay, sorry for delay. Here you get to see the factors affecting the refractive index of a medium. This is very important. First thing first, the nature of the medium, that is its optical density, the physical condition such as temperature, nature of the medium, temperature, then what else? We have the color or wavelength of the light, right? Then if you go down, you have principle of reversibility of the path of light. There's a mirror over here. It strikes, there's a refracted ray, it strikes the glass block or glass slab, it just goes back away at the same medium. Okay. Now, if you go down, the next page, you'll get to see the lateral displacement, which is very important. This is all not required. So lateral displacement, and basically this diagram is very, very, very important. Okay, this one, I'm telling you, this will come for your exam, or they may give you the diagram and give questions, ask questions based on it. Okay, therefore please practice it. Then we have the lateral displacement. You have to remember what factor does this lateral displacement depend on. Okay, it depends on 3 important things. You know what are those? I hope you do. It is the thickness of the block, the angle of incidence, and the angle of incidence, and the refractive index of the glass. It's written again here: thickness of the medium, angle of incidence, refractive index. Then this diagram, they may give or you may draw it. So just practice every diagrams in this chapter. This is very important. Okay. Then these are some of the example sums based on it. Now we have prism. Yes, this is the easiest part of this chapter. Okay. So don't need to worry about it much. We'll just finish it fast. Okay. So prism is a transparent refractive medium bounded by 5 plane surfaces with a triangular cross section. If you go down, this diagram is very important. Okay, this diagram they'll ask you for sure, and this formula just remember for your reference if they give to solve some of the problems. Okay. Now, factors affecting the angle of deviation. This is very, very important. Okay. Just remember this, that the angle of incidence depends, the material of the prism depends, the angle of prism depends, and the wavelength depends. So these are the 4 factors that affect the angle of deviation. Okay. I will go down, and that's it. We finished the prism part. Now see, real simple applications of refraction of light, that is real and apparent depth formulas are very important. Practice it. I'll give you the formulas here highlighted. Apparent depth is equal to real depth divided by constant. Okay. If you go on top, you'll have this. Again, this is very important. Shift equals real depth into 1 minus 1 by constant. Okay. Now, go down. You'll have all those examples about a stick, an eye, and air is rarer, water is denser. So they'll tell you about, they have given you an example about real and apparent depth, and these are some of the example sums problems. This part is an interesting part. Okay, here what you gotta do is simple: critical angle and total internal reflection. So when I is smaller than C, this is what happens. You just have to go through the diagrams and that's it. And when I is equal to C, this happens, and when I is greater than C, then this happens. Okay. Now remember the definition of critical angle. I'm going to highlight it. The critical angle is an angle of incidence in the denser medium corresponding to which the angle of refraction is in the rarer medium is 90. Read it again. Critical angle is an angle of incidence in the denser medium corresponding to which the angle of refraction in the rarer medium is 90 degree. Okay, then I'm gonna go here, scroll down. Remember this formula, 1 by c, 1 by sine c equals cosec c. Then factors affecting the critical angle is very important. By the way, I forgot to tell you about the table, the water, glass, and diamond. 3 things you have to remember. Okay. Water, glass, diamond. So water critical angle is 49, glass critical angle is 42, diamond is 25. Its constant is 1.33, 1.55, 2.41. That is what it is. So now this is important. Factors affecting the critical angle, right? The color, the temperature. Only 2 things important. Now, if you see this diagram, you won't get it. This diagram, right? This is like what? So when you see it at first, you have to observe it properly. So basically, look at this. This is an incident point of incidence. It goes, this is the first ray, strikes normally because this is 90 degree. This slightly tilts because it is not 90 degree and it is making some angle of incidence. Then this is a different angle and this makes 90 degree, the angle of refraction, and this is at again some angle, this makes reflected ray. No, there is no refraction, so this causes total internal reflection. So what do you mean by total internal reflection? Total internal reflection it needs certain conditions, right? It's here, it has certain conditions to follow. So total internal TIR, okay, TIR, when a ray of light traveling in a denser medium is incident at the surface of the rarer medium at the angle of incidence greater than the critical angle of the point of the pair of the medium. The ray is totally reflected back into the denser medium. This phenomenon is called total internal reflection, or TIR. Even if you write TIR in your examination, they'll give you marks. So essential conditions for total internal reflection: the light ray must travel from denser medium to a rarer medium. Okay, so from denser medium to a rarer medium, the angle of incidence must be greater than the critical angle of the pair of media. Now, this is the essential conditions for the total internal reflection, or TIR. Now we're going to go down. This is the difference between the total TIR and reflection from the plane mirror. Okay. Yes. So I guess we finished everything. Yeah. So yes, guys, we finished everything of this chapter. Refraction through plane surfaces. So therefore, and thanks to studiestoday.com, where we got the PDF from. So see you soon in the next video with one more physics or any other subject. I like to finish physics first, so we'll see. If my mood changes, I'll just do anything else. So for now, have a great day. See you. Take care. Stay safe.